So without further ado, let me introduce myself. My name is Dario. This is my colleague who is also named Dario. And the title of our presentation is 500 Days of Ansible. So let's start with the last word of our presentation, which is Ansible. How many of you are actually using something like Ansible or Ansible? Probably all, excellent. You're my kind of crowd. So just a quick introduction to Ansible. Even though some doctors say that the repetitive tasks are actually beneficial to the human brain, because the brain is actually resting in those times, the huge amount of the repetitive task can actually be tedious. So we always want to automate some repetitive task, to remove it from ourselves and to actually have more time for creative thinking. And the Ansible is here to, so let's say, we specify the playbook in YAML format with the specification what he will do to our host. But the reputation of Ansible is on both sides. There is some say that it's good, some say that it's bad. The Ansible is slow and causes delay. Why? That's actually true, because if you would copying, if you would specify the Ansible script in Bash and SSH it to each host and run the Bash script, you will actually get much better performance. But the Ansible is providing you something much more than that. Some other stuff is that the Ansible isn't a programming tool. It isn't. But it doesn't provide the so-called programmer the output from actually the compiler doesn't help in this situation. What you type is actually what you get. So you have to be extremely careful with it. Ansible Tower is some other story, because if you learn Ansible, the Ansible Tower is like learning a different language. And when you're actually expecting the reasonable Ansible error, you can actually get the Python stack trace. As I said, our title is 500 Days of Ansible. Ansible, everybody knows what Ansible is, but why 500 days? Has anyone heard about one pretty peculiar movie, 500 Days of Summer? Yes. It's actually not a love story, so if you don't like a really great ending of a movie, you shouldn't watch it. But the movie actually goes that the main character, the guy, meets the summer at his work, and they actually fell in love. And the relationship at the first stage is actually purely physical. And as you would think, the relationship has to grow from the physical side to the emotional side. But they aren't really connected. And further in the movie, they're much further apart. And they actually, at the middle of the movie, or at 250th day, they actually broke up. And all other part of the movie, he's actually all of her beautiful things that he used to thought are now her flaws. And at the end of the movie, he actually meets a new girl, which is called Autumn. And the question remains, will he repeat the same mistakes with the previous girl? Why didn't he allow him to move the relationship even further than that? So our task here is to actually move your relationship with Ansible to a much higher level. And why do we need to do that? Because Ansible is, after all, very easy to start with. It's really easy to enter into some fast course and to you see 2 or 3 examples, and you think you know absolutely everything. And when you run your first playbook, you probably have a smile on your face with hooray, because you automate something and you see that it is actually working. But there is some beauty underneath all of that. And if your relationship actually grows, at some point you will start to hate Ansible. But that's a natural approach. So with learning pretty much everything, there is a famous learning curve, Dunning-Kruger. And our task here is for all of you who is actually stuck at Child Hill, who actually think that you know everything. Our task here is to question your current knowledge, to move you into insecure canyon, and then give you the hand to move it from the insecure canyon to the growing up a mountain. And how we will actually do that? We will actually pass through some really strange design patterns in Ansible, which aren't actually clear at the first, but it will at the end of the presentation. And I will let my colleague Dario here to present them.
Thank you. So those are the couple of design patterns that we will go through today. At first, they might look a little bit strange to you, but please open your hearts and mind, because they will show Ansible in its fullest state. Those are, as you will see, delegate 2, should you use vault or no, dry principle, do not repeat yourself, hash merge, and lazy evaluation. When we think of Ansible, we are imagining a bunch of repetitive tasks that are all performed at once at high number of hosts. But can we delegate certain tasks to certain hosts? So, do all of the hosts need to perform all of the tasks? Just a moment. So let's back to the classical Ansible pattern. You have your playbook, and you're running those playbook on a large number of hosts. And if you want to run another playbook on another set of hosts or host, fine. You will need to run another playbook. But what happens if they are part of the same logical unit? Can you merge them together into one playbook? With delegate 2, you can do it. So you have your playbook, and you are running it on 2 hosts. But then, if you want to delegate certain tasks from inside that playbook to be run on another host that is not part of the inventory that you are running playbook 2, you can use delegate 2. How does it work? In the example. So this is the example of our task that is running a license compliance audit. We are running it every year, or more than 500 hosts, and we're using Ansible for it because it's too much manual work if we would do it by hand. We have a task that copies the audit scripts to the hosts. Then we are running the scripts. After the script is done and it exports its output file, we are copying that output to the shared folder on the hosts. And then, instead of running those 2 tasks on each and every host, we are delegating this task to the local host. The local host also is connected to the shared folder. It copies the output for each and every host to the FTP server, and at the end it removes those files. So we are running only one playbook and are targeting different inventories and different hosts. Next one is, should we use Vault or no? There are two kinds of people, the people who use Vault and people who will use Vault. Because if you're storing your passwords in a Git or any other repository of code in clear text, this is a big problem. But what if you don't want to use Vault? Is there another way, a third way? What else can you do? You can use something that is called Ansible Environment Lookup plugin. How does it work? So you're storing in your main default YAML file, you're storing your variable that points to the environment variable test password on the host. And if this variable does not exist on the host, you are defaulting to none. So this is defined on your default YAML file for all playbooks. Now, if you go to the server, inside the bash profile of the Ansible user, you are exporting the password that you will be using. And this is the password that points to the test password on the Ansible level. So now inside your YAML definition, first you're valuing that in this password really is set and it exists. If not, you are defaulting to error and you're giving out the output that that password does not exist set on the host. If it exists, the Ansible can use it. You can create the new user. Additionally, ensure that this user is not that this password will not expire in the future. And after everything is done, you can remove this password from the bash profile that is from the host. So in this example, you are basically passwords do not travel over the network. Passwords stay on the host side. And basically, in this way, you don't need to use Vault, but it is only applicable in some situations like host preparations or defining users that you know will be there to stay, but it is not, of course, applicable for every situation. And these are the outputs. So if you are erroring out, the output will stop at the second task. If we have this password defined, it will go to the end. Another design pattern is do not repeat yourself. So this is when we ask ChatGPT to give us the code that will install these 6 Linux packages on the server, he has given us a code that works, and there is nothing basically wrong with this code, except there is one small thing. It is not very optimal. So in this example, you are invoking the YAM model multiple times, 6 times in this case. Could be this done in some other way, more optimal way. If you go to the Ansible documentation and basically search for just a moment, for the documentation of the loops, you will see that there is a non-optimal way to use loops and the optimal way. So non-optimal way will go through the loop to the list of packages in a loop and invoke a command for each of them. Optimal ways is you just use the variable array. So you're specifying a list of the packages and an array. In this case, you will be invoking YAM command only once. You will have no issues with interdependencies, and also with that you will not be building 6 times the cache, and you will not fetch the repository 6 times. So much optimal way. Another one is about dictionaries. How to merge dictionaries. So what happens? You have your dictionary set in this way. So what happens if you want to change the size of your while logical volume variable from 3 gigabytes to 10 gigabytes by default merge behavior in Ansible? Does anybody have an idea what will happen if I define this on a host level and if this is defined on the playbook level? by default nothing will happen. We will replace everything with the definition that you have decided on our host level. How can we override this? We can use Ansible, we can change Ansible hash behavior to merge. And in this situation, when we define some variable on the host level that is overpowering the dictionary on a playbook level, we will be changing only the value that we have defined and keeping everything else intact. So to give you the abstraction, when we use default merge behavior, we are breaking everything and keeping only the definitions that we have defined. And we are merging merge behavior, we are adding our puzzle to the end of the puzzle itself. There is one more concept that we will go through. I will give my colleague Dario a microphone back, and this is lazy evaluation.
Okay, thank you. Let's start with an example from Bash. So let's define a variable A containing DORS, variable B containing CLUCs, which is actually an error, and the variable C will actually be A/B. But we figure out that the variable B should be CLUC, and we want to print the variable C. What the output of variable C will be. Sadly, it will be DORS CLUCs, because the variable C was actually evaluated in the third step. And this is what it's called an eager evaluation, but the Ansible doesn't actually evaluate variables in that manner. It's actually evaluating at the time it's actually really needed. And the variable C is actually needed only at the last step. In the Ansible, this will actually be DORS CLUC. So we can actually imagine that the A and B are defined on the global level at the playbook, and the variable B is actually overridden at the host variable level. And this is actually pretty nice pattern. So we have an lazy evaluation, which is actually an evaluation strategy that delays the evaluation of the expression. It's actually the most commonly used in Ansible effects, because the Ansible effects aren't actually evaluated until you actually needing them in your playbook. And the second one is actually an eager evaluation. It's mostly common in all other programming languages, but some of the, for example, functional programming languages are actually using are not using the eager evaluation, are actually using the lazy evaluation, and we give them an ability to actually have their infinite list. For example, the Haskell is one example. So it actually reduces the unnecessary computation and the enhanced scalability, and it's actually giving us the ability to actually only override some some small part on the host that actually needs to be overridden, and the global part can actually stay at the global level. So let's see some sort of an example. We want to download something, and we have we know about variables in Ansible, so we want to use download link. It's actually using HTTPS download me/here, but our host doesn't have a certificate exchange, so we have to downgrade it to the HTTP. So never mind, on some other host we will actually completely repeat all the link. But if you at some point change that link download me, you will actually have to change at every host level. But you actually want to save that download me in the global variable area. So you don't need to specify all download link. You actually only need to specify the HTTP protocol, and actually he will be overridden from the global side, because the download link will actually be evaluated at this step, and it will actually contain the right protocol, not the HTTPS. The second example, something more useful, it's configuring the DNS in network scripts. For example, you have an interface name which is it has a 0, and you have an interface configuration file. If for example, all you're playing your playbook on virtual machines, and all your virtual machines have an interface HT0, but if you're playing them on some physical machine, then probably your interface will have some other names, and you don't want actually to override and to specify the entire interface config file at the host level. You want is something like this. This will be actually really wrong. What you actually want to specify is only the interface name at the host level, and it will actually be evaluated at the correct level. So you're actually keeping the all what the host doesn't need to know about the location of that script. This actually belongs to the global level, because that's actually common to all hosts, and it shouldn't be actually we shouldn't find it at the host variables. And at the end, the story about Soros Apprentice. Does anybody know the story from the German author Goethe? It's actually the story about a magician who was so eager to learn the magic, so he learned the broomstick to carry the water instead of him. But he was so eager to learn that magic, but he didn't learn how to say the broomstick to stop the carrying the water. So the point of that story is actually let's give ourselves some time to learn the technology that we're actually using, so we actually avoid some bad code, which is not actually using the full line of capabilities that Ansible are actually providing us. So thank you. You're probably a question about combine. Am I right? No?
So I was kind of wondering, but it's probably related a bit to lazy evaluation you talked about, and it's basically import role versus include role, and how you usually, what principle do you use when to select one or another, because they kind of both mess up with you if you are using it inappropriately. So is your way around it?
That's actually a great question. When you're actually deploying, when you're actually doing a provisioning with Ansible, it's actually generating, for example, a new deployment in Kubernetes. It's actually a full YAML, and it's basically giving the most. The old thing that you can actually override. You can override the interface name or something like that, and you actually write your Ansible playbook that those variables are that you can actually change them without changing your playbook. It's actually only changing the variables that you're passing to the host.
Yeah, so basically the issue with import roles versus include roles is that if you are doing import and you are not careful enough and don't overwrite a variable to the role, but it's defined somewhere in group vars, for example, it will be passed like as default to the imported role and will overwrite it default when it's not needed. For example, even if not. And then if you're doing import role and you want to listen or trigger handler from a previous level, for example, in the included one, so if you import this handler may be referenced only after you're doing import, rather when Ansible evaluate the whole playbook. So basically, well, in one case you are like messing up a bit with scopes, and you might pass variable you are not attend to some role, and
that's why when you're actually trying something new, you always have to use debug. Am I?
Okay, and probably the second was you was talking kind of about optimizations, slash tunneling and stuff. Was you using inject facts as vars because it's really improving the speed?
Can you please repeat one more time?
Inject facts as vars, disabling it. So basically, you don't have any more Ansible facts, because when you have a lot of variables defined on group level, or basically when you have a lot of variables defined, it slows Ansible a lot. So reducing at least amount of facts that are defined as independent variables will speed the execution of tasks a lot.
But how much variables do you actually need? Not many, because the Ansible facts are actually providing you with a lot of variables that you're.
Yeah, but
for example,
so the thing is, if you disable inject facts as vars, you will have only one variable Ansible facts, and then it will be a dictionary. But if it's enabled, which is default behavior, each fact will be also, in addition to that, will be as additional variable. So disable it, giving like quite significant performance on execution.
I don't know how to answer that question, but we can talk later regarding that, okay? Anyone? Thank you. Thank you for your attention.